is the Chapter 5 summary. Ethernet operation, the LLC and MAC sublayers. Ethernet, it is one of the most widely used LAN technologies. It operates in the data link and the physical layer. It is family of network technologies that are defined in the IEEE 802.2 and 802.3 standards. Supports data bandwidths of 10, 100, 1000, 10,000, 40,000, and 100,000 Mbps or 100 Gbps. The Ethernet standards, it defines layer 2 protocols and layer 1 technologies. It is the two separate sublayers of the data link layer to operate, which is the logical link control and the MAC sublayers. This picture is the Ethernet. Ethernet is defined by data link layer and physical layer protocols. This data link and physical has its Ethernet, which is 802.3 and 802.3. LLC handles communication between upper and lower layers, takes the network protocol's data and adds control information to help deliver the packet to the destination. MAC, it is constitute the lower sublayer of the data link layer. It is implemented by hardware, typically in the computer NIC, and it has two primary responsibilities, which is the data encapsulation and media access control. The MAC sublayer data encapsulation has frame delimiting, addressing, and error detection. Media access control has control of frame placement on and off the media and media recovery. This figure shows the physical layer. MAC sublayer, the data encapsulation. The frame assembly before transmission and frame disassembly upon reception of a frame. MAC layer adds a header and trailer to the network layer PDU. Provides three primary functions, which is the first one is frame delimiting, identifies a group of bits that make up a frame, synchronization between the transmitting and receiving nodes, addressing. Each Ethernet header added in the frame contains the physical address or MAC address that enables a frame to be delivered to a destination node. The last one is error detection. Each Ethernet frame contains a trailer with a cyclic redundancy or CRC of the frame contents. MAC, responsible for the placement of frames on the media and the removal of frames from the media. It communicates directly with the physical layer. If multiple devices on a single medium attempt to forward data simultaneously, the data will collide, resulting in corrupted, unusable data. Ethernet provides a method for controlling how the nodes share access through the use of carrier sense multiple access or CSMA technology. Media access control, carrier sense multiple access process. It used to first detect if the media is carrying a signal. If no carrier signal is detected, the device transmits its data. If two devices transmit at the same time, or the data collision. CSMI is usually implemented in conjunction with a method for solving media contention. The two common use methods are CSMI or collision detection and CSME or the collision avoidance. CSMI or collision detection. The device monitor and media for the presence of the data signal. If a data signal is absent, indicating that the media is free, the device transmits the data. If signals are then detected that show another device was transmitting at the same time, all devices stop sending and try again later. While Ethernet networks are designed with SMA or CD technology, With today's intermediate devices, collision do not occur and the process utilized by CMA or CD are really unnecessary. Wireless connection in a LAN environment still have to take collision into account. Ethernet frame size. Ethernet 2 and IEEE 802.3 standards define the minimum frame size as 64 bytes and the maximum as 1518 bytes. Less than 64 bytes in length is considered a collision fragment or runt frame. If size of a transmitted frame is less than the minimum or greater than the maximum, the receiving device drops the frame. At the physical layer, different versions of Ethernet vary in their method for detecting and placing data on the media. This figure shows the extra 4 bytes allows for QoS and VLAN technologies. The figure displays the fields contained in the I02.1Q VLAN tag. Introduction to Ethernet frame. Preamble and start frame delimiter field is used for synchronization between the sending and receiving devices. Length or type field. It defines the exact length of the frame's data field that describes which protocol is implemented. Data and pad fields. It contains the encapsulated data from a higher layer, an IPv4 packet. MAC address and hexadecimal. This figure shows the decimal and binary equivalence of 0 to F, the hexadecimal, and selected decimal, binary, and hexadecimal equivalents. Unicast MAC address. This figure shows the unicast. Unicast and MAC destination address are used by the source to forward a packet. Broadcast MAC address. Broadcast IP and broadcast MAC destination addresses are used by the source to forward a packet to all hosts on the network. Multicast MAC address. Multicast IP and MAC destination addresses deliver packet frame to a specific group of member hosts. Multicast MAC address is special value in that beginnings with 01-00-5 in hexadecimal and range of IPv4 multicast addresses is 224.0.0.0 to 239.255.255 and .255. MAC and IP. MAC address. This address does not change. It is similar to the name of a person, known as physical address because physically assigned to the host NIC. IP address. It is similar to the address of a person based on where the host is actually located, known as a logical address because assigned to each host by a network administrator. Both the physical MAC and logical IP addresses are required for a computer to communicate, just like both the name and address of a person are required to send a letter. ARP functions or operation. ARP table. It is used to find the data link layer address that is mapped to the destination IPv4 address. As a node receives from the media, it records the source IP and MAC address as a mapping in the ARP table. ARP request layer to broadcast to all devices on the Ethernet LAN. The mode that matches the IP address in the broadcast will reply. If no device responds to the ARP request, the packet is dropped because a frame cannot be created. The figure shows the ARP operation, the ARP process to communicating locally. Cut-through switching. Fast-forward switching. It is the lowest level of latency. Immediately forwards a packet after reading the destination address. Typical cut-through method of switching. Fragment-free switching. Switch stores the first 64 bytes of the frame before forwarding. Most networks error and collision occur during the first 64 bytes. A cut-through switch forwards the frame before it is entirely received. At a minimum, the destination address of the frame must be read before the frame can be forwarded. In addition, Ethernet is the most widely used LAN technology today. It is a family of networking technologies that are defined in the IEEE 802.2 and 802.3 standards. Ethernet standards define both the layer 2 protocols and the layer 1 technologies. For the layer 2 protocols, as with all 802 IEEE standards, Ethernet relies on the two separate sublayers of the data link layer to operate, the LLC and the MAC sublayers.